Welcome back, Cosmic Explorers. Caroline here, and I don't know about you, but I love looking up at the sky on a clear night. When you look up at the night sky and see countless stars and galaxies, have you ever wondered just how far you're really looking into space? How big is the universe? Does it go on forever? And those aren't the only big questions. How old is the universe? Has it always been here? Will it last forever? For thousands of years, humans have asked these questions, but it's only in the last century that we've begun making real progress in answering them. And there's still a lot we don't know. Many of these mysteries are the focus of today's cutting-edge research. So, let's take a journey through space and time to start uncovering the universe's secrets. Today we'll explore just how immense the universe is and how the light we see from distant objects reveals not only their present, but their past. Along the way, we'll learn how astronomers measure distances in the universe, and we'll look at where we, as humans, fit into this cosmic timeline. The first question we asked today was, how far can you look into space? To answer that, we need to take a closer look at something you use every day, something that makes it possible for you to see this whole video right now. Any guesses? Light. You can see this video because your screen is emitting light. And when you look around at furniture, books, or maybe trees outside your window, you're actually seeing the light that's reflected off those objects. Without light, there's nothing to see at all. When you flip a light switch, it feels like the light instantly fills the room. But did you know that light doesn't actually travel instantaneously? While it moves incredibly fast, light has a finite speed, about 300 million meters per second, or roughly 670 million miles per hour. Let's put that into perspective. The sun is about 93 million miles away from Earth. So how long does it take for its light to reach us once it leaves the sun's surface? Seconds? Minutes? Hours? What's your guess? It takes about 8 minutes. This means that we always see the sun as it appeared 8 minutes ago. What about something much farther away? Let's consider the closest star system to our sun, Alpha Centauri. Its light takes over 4 years to reach us because it's 25 trillion miles away. And you thought your last road trip was long. When possible, we'd rather not have to deal with values this large because they are unwieldy when making calculations. So scientists came up with a new unit, the light year, that we can use when referring to very large distances. Let's find out how to measure with this unit. Since the light from Alpha Centauri takes about 4 years to reach Earth, we say that Alpha Centauri is 4 light years away. So what do you think a single light year represents? How is it defined? A light year is the distance that light travels in 1 year in the vacuum of space, and is equal to about 6 trillion miles. Even though it has the word year in it, a light year represents a distance, not an amount of time. Here's a quick quiz for you. If Alpha Centauri is 4 light years away, how old is the light we're seeing when we look at it through a telescope? Go ahead, pause the video, and make a prediction. The answer? The light we're seeing is 4 years old, meaning we're seeing Alpha Centauri as it looked 4 years ago. This is why measuring stellar and galactic distances in light years is so convenient. We can immediately tell not only how far away the object is, but when we are observing it from. If we were to look at the Andromeda Galaxy through a telescope, we would see what it looked like millions of years ago because it is over 2 million light years away. It's almost like we have a built-in time machine that lets us look back into the history of the universe simply by observing the light we see from it. Let's get back to our original question now that we have appropriate units to measure it with. How far can we see into space? The most powerful telescopes we have today can detect objects nearly 14 billion light years away from Earth. This distance is often called the cosmic horizon, or the edge of the observable universe. Does that mean there's more beyond this horizon that's not observable? Astronomers think so. But why can't we see any farther? It's not a limitation of our technology. It's the laws of physics working against us. To understand why, let's explore another big question. How old is the universe? Much of what we know about the distant universe comes from stunning images captured by the Hubble Space Telescope, and more recently, the James Webb Space Telescope. These powerful telescopes orbit Earth from space, allowing them to observe the cosmos without interference from our atmosphere. Take this deep field image, for example. It shows a tiny section of the sky, so small you could cover it with your finger. What do you think each bright object here represents? Most of them are galaxies, some of which are so far away that they appear as tiny, fuzzy blobs. These are some of the farthest galaxies that we can detect, 14 billion light years away. That means the light we're seeing from them began its journey toward Earth 14 billion years ago. So if this light has been traveling for 14 billion years, what does that tell us about the age of the universe? Well, the universe must be at least 14 billion years old. Otherwise, the light wouldn't have had time to reach us. Because as far as we know, it would have been impossible for light to travel or even exist before the universe formed. If the universe were any older, we would likely be able to see objects that are farther away than 14 billion light years. This is why astronomers estimate that the universe is around 14 billion years old. When we observe these farthest galaxies, we're actually looking at the universe as it was shortly after it began, because the very first light it emitted is just now reaching us. We're seeing the early universe. So, while the time machine effect of light speed doesn't make much difference in our own solar system, it leads to groundbreaking discoveries when we look deep into the cosmos. If the universe has existed for nearly 14 billion years, what's been happening during all that time? Has our solar system been around for all of it? Actually, no. Our solar system didn't form until about 4.6 billion years ago, roughly 9 billion years after the universe first began. In cosmic terms, that makes our solar system pretty late to the show. It's like walking into a movie when it's already more than halfway over. So what did we miss? What was going on in the universe before we arrived? As far as we know, countless stars and galaxies were being born, going through their life cycles, and eventually dying, sometimes violently. Their remains would have spread across the cosmos, seeding new star systems as the cycle continued, just as it does today. In other words, the universe's past probably looked a lot like its present. Now, what about us, humans? Have we been around for all of Earth's 4 billion year history? Not even close. The earliest fossils of modern humans are only about 300,000 years old. While that might sound like a long time, it's actually just a tiny blip on the timeline of the universe, about 0.001% of the universe's entire history. To really understand how brief human history is on a cosmic scale, let's imagine compressing all 14 billion years of the universe's existence into a single year. On this scale, when do you think human civilizations would appear here on Earth? Make a prediction, pause the video, and guess a specific date. On this cosmic calendar, all of human civilization would fall within the evening of December 31st, New Year's Eve. On this last day of our cosmic year, the earliest form of writing, it would emerge in the final minute before midnight. And the Industrial Revolution in the 1700s? It occurs in the final second before the clock strikes 12. Our time here has been incredibly brief in cosmic terms, but look at how far we've come in such a short period. How much further do you think we'll go? And how much more will we discover? That's up to you. There's still so much out there waiting to be explored, and your generation will have no shortage of mysteries to solve in our vast universe. Well, Cosmic Explorers, that's a wrap for today. See you next time as we journey further into the universe.
Hey, hey.